Okay, this is lesson 4.2. It's the second lesson of solving systems of equations in Math 20-1. Today we're going to solve systems of equations by using the elimination method. Yesterday you guys learned how to solve these equations using the substitution method, which works really well when you have a variable that's already isolated. But sometimes that's not always the easiest way to do things. So solving by elimination is just another method of doing the same thing, but it's when there's certain situations that are more useful. And it's hard to describe, but you'll see here in a minute what I mean by different situations that look a little bit easier to use elimination than substitution. So this first example, they have already completed for you. So you'll notice that there's two equations here. You have equation 1 and equation 2. And you'll notice that these equations aren't set up where one variable is already isolated. When one variable is already isolated, using the substitution method from 4.1 is very easy and convenient. In this situation, we don't have an isolated variable, meaning we don't have a variable by itself on one side of the equal sign. So that's why we're going to choose to use elimination. This is a linear system, which came from Math 10C, so this should be very familiar. In a linear system, we set up our equations so that they're in the same order. Notice that equation 1 has x's go first, its y's go second, then the equal sign, and then the constant. And equation 2 has the exact same setup. X's, y's, equal sign, constant. Once you have those set up, your second goal was to make sure that either your x's or your y's, there was the same amount of them. You'll notice that we have only one x in the first equation. There's only one here. And you'll notice that there's 2 here. So the x's aren't the same. If you look at the y's, there's one y here and one y there. In equation 1, it's a positive 1y. In equation 2, it's a negative 1y, but they're both 1y. At that point, if you remember from Math 10C, we decided that we had to either add or subtract these two equations together. If the variable that has the same number of things, so this one, we're talking about y, so because there's one y in the first one and a negative y in the second one, if they're opposite signs, then what you're going to do is you're going to add the two equations to each other. When you add the two equations to each other, you're going to have negative x plus 2x equals 1x. You're going to have y plus negative y equals nothing. They cancel out. The equal sign is still there. 2 plus 4 is 6. You'll notice that by adding the two equations, now you only have one variable left. And in this case, it's x. So we have x equals 6. Once you know one variable, just like in 4.1, you take that one variable and you substitute it back into one of the equations. So notice that they have equation 1 right here, and they changed x to be 6. By changing x to be 6, they were able to solve that y equals 8. And again, they wrote their solution as a point. Because just a reminder that every time you solve a system of equations, you're actually finding a point on a graph. You're finding a point where both equations have the same x and y value. Okay, we're going to do equation right here below. It's another linear equation, meaning that there's no x squared terms. And we're going to try to solve this thing. So, we have 5x minus 4y equals 14 in equation 1. In equation 2, we have 2x minus 3y equals 10. The first step is to make sure things are in the same order. So x's, then y's, then equal sign, then constant. X's, then y's, then equal sign, then constant. They're the exact same order. They're right on top of each other. We do that on purpose because it's going to make our lives a little bit easier later on. Okay, once we have them in the same order, our second step is to get either the x's the same or the y's the same. In this case, the x's are different. There's 5x in the first one and 2x in the second one. And the y's are different. There's 4y in the first one and 3y in the second one. So we have to somehow change these so that they're the same thing. I'm going to work with the x's. Sorry, we had a little interruption there. But I'm going to focus on the x's. I'm going to focus on making the x's have the same number of things. You could focus on the y's, and that would work the same. But I'm going to focus on the x's. And I'm going to try to make 5x and 2x be the same, and I'm going to use multiplication to do so. So if I want to make 5x and 2x be the same number through multiplication, what I'm looking for is the lowest common multiple between 5 and 2. And if you remember what lowest common multiples, that means the lowest one would be 10, because 5 times 2 would be 10, and 2 times 5 would be 10. So I'm going to multiply this entire first equation by 2. And I'm going to multiply the entire second equation by 5. And when we do that, we get equation 1 is going to become 10x minus 8y equals 28. And the second equation is going to become 10x minus 15y equals 50. Now, if you did this right, you should notice that you have one variable with the same number of things. Notice we have 10x and 10x. Those are the same amount. Once you have the same amount, you have to decide whether you want to add or subtract your two equations together. If my x's had the same positive or negative, like the same symbol in front of them, we want to subtract the equations. So because this is a positive 10x and a positive 10x, I want to subtract the two equations. 10x minus 10x is going to cancel out. Negative 8y minus negative 15y. So if I'm minusing negative 15y, it's really like I'm adding 15y. So I have 7y's. Equals 28 minus 50 is going to give me negative 22. Okay, at this point, what I want to do is I have figured out that I have one variable left. If you do elimination properly, you should always have one variable left. In this case, we do. We only have y's left, so that's a good sign for us. When you have one equation and one variable, you can solve for that one variable. To do that, we're going to divide both sides by 7. So we have y equals negative 22 over 7. And that's fantastic. Like, we figured out what y is, that's good, but that's really half the question. Because remember, when we're doing systems of equations, we're trying to find x and y values. So we need to somehow use this y value to find our x value. To do that, we take our y value, and we're going to substitute it in to one of our equations. I'm going to choose equation 2. You really could choose any equation you want. Sorry, I was pointing my arrow the wrong way. You just sub it in for y. You can choose either equation. You can choose equation 1 or equation 2. I'm just choosing equation 2 by random choice. It makes no difference. Once you substitute it in, you're going to write it all out. So you've got 2x minus 3 times, instead of y, we now have negative 22 over 7 equals 10. Now we're going to do a little bit of math here. So if you do 3 times, sorry, it's negative 3. If you do negative 3 times 22 over 7, and that's a negative 22, of course, and then you math, bracket, and your calculator, you should get 2x, and that can combine to become plus 66 over 7 equals 10. We're going to subtract 66 over 7 from both sides, so 10 minus 66 over 7. We're going to math frac that again, and you're going to get 2x equals 4 over 7. Now we're going to divide both sides by 2, and you're going to get x equals 2 over 7. Again, I just used my calculator to figure out those fractions. Took my time, used brackets, used math frac when needed. Now I have a y value and an x value. I can write my answer properly as a point. So 2 over 7, comma, negative 22 over 7. That's the point where those two equations would cross each other. It's the point where both of them could have an x value of 2 over 7 and both of them have a y value of negative 22 over 7. Okay, that's a review of Math 10C. So if you want to try another one, this is a good practice problem. So you can go ahead and try that. When you do that one, you're going to have to multiply them. You're going to get an answer of 1, 3. So when you're done that question, you should have x equals 1, y equals 3. Below, we have another example, and this new example is a quadratic system of equations. So that's how this stuff goes from Math 10C to Math 20-1 level difficulty. Quadratic means you have x squared terms. Now, in my opinion, quadratics really aren't that much more difficult. They're actually usually easier to use elimination. They're a little harder to solve, though, after you do your elimination step. But in the end, they're really the same level of difficulty as Math 10C. So, we have to solve this quadratic equation using elimination. So we look at our equation. The first thing we want is we want to set up our equation 1 and our equation 2 to look the exact same. We want y's, then equal sign, then x squared, then x, then constant. If you look at equation 2, it's the same way. Y's, then equal sign, then x squared, then x, then constant. Excellent. Now we have to decide if we want to try to eliminate our y's or our x's. In quadratic systems, it's almost always easier to get rid of the y term. My reasoning being, if I tried to get rid of my x's, I have to get rid of all my x's. So I don't just have to get rid of these x's, I also have to find a way to get rid of my x squares. So that means I'm going to be trying to find the lowest common multiple between 2, negative 7, positive 6, and negative 1. Like all those constant terms. And that's going to make things really difficult. Instead, it's going to be a heck of a lot easier if I try to find my y values to be the exact same. And in our case here, we have 1y and 1y. That's much easier to eliminate. There's already only one of them, and there's only one y. Like there's not two different y terms. Where in the other ones you saw there's x squares and x's. Okay, once we decide we want to eliminate, we have to make sure we have the same number of both, which we do. We have one y in the first equation and one y in the second equation. Now we have to decide if we want to add or subtract. We're going to subtract because they're both positive y's. Anytime they're the same symbol, whether positive or negative, you're going to subtract your equations. If they're opposite, then you want to add. Y minus y is 0 equals 2x squared minus negative x squared is 3x squared. Negative 7x minus 6x is negative 13x. 3 minus negative 7 is plus 10. We've successfully eliminated one of our variables. Now we have one equation with one variable, that variable being x. Now we have to use our knowledge on quadratics to solve this equation. We have an equation that's a quadratic. We need it to be in general form and equal to 0 to solve. Just like Unit 2, just like Unit 3. So we've got a quadratic equal to 0. We have 3 ways to solve this thing. We could diamond method it, we could box method it, or we could quadratic formula it. I'm going to try to diamond method it. So I set up my diamond. I want to add, multiply by 10, add to be negative 13. Sorry, by 10 I mean 30. Two numbers that would multiply to be 30 and add to be negative 13 would be 15, negative 15 and 2. That means I have 0 equals 3x minus 15, 3x plus 2. I divide this one by 3. So I have 0 equals x minus 5, 3x plus 2. At this point, I can now solve it because I'm in factored form. So I need to use my zero product property to tell me that x equals 5 or negative 2 over 3. If I have two x values, that means I probably have two different points where these things cross each other. That means I'm going to have to substitute x equals 5 in, and I'm also going to have to do x equals negative 2 over 3 into one of the equations. I'm going to choose equation 2, so I'm going to substitute 5 into the x, and it goes to both x's. So I'm going to have y equals negative, and then in brackets we got 5 squared. Remember, anytime we're substituting, we use brackets. And then minus 7. That's going to tell me y equals, if I punch that in my calculator, so I've got negative 5 squared plus 6 times 5 minus 7. I'm going to get that y equals negative 2. Now, that y equals negative 2, it happened when I substituted x equals 5. So that means this is only one answer. It's 1 point. It's 5, comma, negative 2. That x equals 5 was attached to that y equals negative 2. Okay, we now have to do it again. So we substitute the negative 2 over 3 in. And we have negative 2 over 3 squared plus 6 times negative 2 over 3 minus 7. Again, we're going to punch that thing into our calculator. So we've got negative bracket 2 divided by 3 squared plus 6 times negative 2 over 3 minus 7. And we need to math track that thing. And I got negative 103 over 9. So once we have a y value, remember that y value is attached to an x value. So that's 1 point together. It was negative 2 over 3, comma, negative 103 over 9. So 3. Excellent. So we have a couple more examples of this. So again, we have an equation here. You'll notice that this one has a quadratic in it, but it's not a quadratic equation. It's a quadratic linear equation, because the first one is a linear. It's not actually quadratic. But to solve them, we still do the same thing. So it doesn't matter if we have linear, quadratic. We solve it doing the same thing. And to solve through elimination, the first step is you have to have those things looking the same. So you need to have your y's in order, your x squareds in order, your x's in order, and your constants in order. And in our case, we don't have that. Notice that we have y's in order, But then this one has an equal sign, and this equal sign is way over here. You'll also notice that the 2x on up here is not in the same spot as the x over there. So what I'm going to do is I'm going to reorder this first equation to become y equals 2x plus 6. So I added that 2x to both sides to move it over. I'm then going to write out that equation underneath my second equation so that it's in the same order. So now I'm going to go y equals, I don't have any x squares. So what I'm going to do is I'm going to purposely leave a little blank space right here because I don't have any x squares. And then I'm going to go 2x plus 6. I left a blank there. You don't have to. The reason I leave a blank there is so that I remind myself, like, there's 0 x squares in that second equation. Okay, once I have them in the same order, my goal is to have the same number of x's or y's. I already have the same number of y's. They're both positive, so I'm going to subtract these equations because y minus y is going to give me 0 equals x squared minus no x squares, because there is no x squares in that second one. I'm still have x squared. X minus 2x is negative x. Negative 6 minus 6 more is negative 12. If you successfully did elimination, you should now have one equation with one variable. In this case, 2. One equation, all I have left is x's. I have to now decide how I'm going to solve this thing. It's a quadratic, so I either have to factor it, diamond method it, so box method it, or quadratic formula it. I'm going to diamond this thing. So things that multiply to be negative 12 and add to be negative 1 are going to be negative 4 and 3. That thing is going to be x equals x minus 4, x plus 3. Sorry, that should be x plus 3, 0 equals. Once we're done factoring, we can use our zero product property to sub this thing in. So we now have x equals 4 and negative 3. That's great. You know what x equals? That's only one thing. Now I'm going to take that variable for x, and I'm going to sub it into one of my equations. I'm going to sub it into this equation right here. My reasoning for picking that is that's a really easy equation that I have. Y equals 2x plus 6. That's pretty simple. It's just y equals 2 times 4 plus 6. That means y equals 8 plus 6 is 14. So my first point will be at 4, 14. Remember, we write our things as points, and whatever variable you use, you have for x is attached to that variable you use for y. Okay, now that we have 1 point, we need to do something with this second x value. We're going to take x equals negative 3. We're going to substitute it right into the same equation. So we have y equals 2, negative 3 plus 6. You put that in your calculator, and you get y equals 0, meaning that your next point is negative 3, 0. So those are both your answers. Like, those are both valid solutions. Neither one's wrong, both are correct. Okay, we come down here, we've got our last question, or second last question. We need to solve through elimination. It is quadratic and quadratic. This looks completely different though. If you look at this thing, we notice we probably have a big problem that says that this quadratic equation is definitely not in a form that we're used to. This thing is in factored form, sneakily, so we need to get it into general form before we can even start working with it. To get it into general form, we have to expand. Hopefully you remember that from Unit 3. Anytime you want to convert something to general form, you need to expand it. When you expand it, you get y equals negative x squared minus 6x minus 9. That negative stays on the outside of the brackets. You multiply a binomial by a binomial, then you multiply the negative. So this one is gone. We then make sure our things are all in a line. They are. We have our y's, and then our x squares, and our x's, and our constant. The y's are the exact same, so we're going to subtract. That's going to give us 0 equals 2x squared minus a negative x squared will be 3x squared. 11 minus negative 6x is going to give us plus 17x. And then 12 minus negative 9 is going to be plus 21. We have successfully done elimination because we're down to one equation with one variable. Now the problem with this thing that we're going to notice is that if we tried to diamond method it, we can't. It doesn't work. And that kind of makes sense when we read the question, because when we read the question it said x coordinate as an exact value. Usually when you see the terms as an exact value and then you see y to the nearest 10th, that's probably a sign that our values are going to be irrational numbers or really awful decimals, which means we're probably not going to be able to factor it. Like that just kind of is a good hint if you do enough math that when you see things like exact value, it means you're probably going to have square roots or something like that. If we can't factor, which we can't factor this thing, we have a different choice, and that choice is to use the quadratic formula or the box method. I'm definitely going to use the quadratic formula. So I'm going to fill out my quadratic formula as y equals negative b, so negative 17, plus or minus the square root of b squared, so 17 squared, minus 4 times a, which is 3, times c, which is 21. All divided by 2a. We then go ahead and we simplify that thing, so everything inside the brackets we want to simplify, so 17 squared minus 4 times 3 times 21. We're going to have y equals negative 17 plus or minus the square root of 37, all divided by, oh, I wrote 2a, that should be 3. All divided by 6. Okay, we have two x values here. Holy smokes, Mr. Kennedy. The quadratic formula is not y equals, it's x equals. We have two x values here. The first x value is if we use the plus, the second x value is if we use the minus. So you're going to have to take both of those and sub them in. When you sub them into your equation, you're going to take negative 17 plus root 37 minus 6. You're going to plug that thing in to one of your equations. You can plug into this one that we canceled out, or we can plug it into this thing over here. It's your choice. But when you do that, you're going to get y equals, you're going to get y equals negative 1.4. That's if you use the plus. If you use the minus, you're going to get y equals negative 0.7. Again, it's good you got x values, it's good you got y values. I got those y values by just putting those awful numbers for x into my calculator. I used decimals, so I put that negative 17 plus root 37 divided by 6 in my calculator to get decimal, and then I put that decimal into the quadratic, and it gave me those y values. You always want to write these as points, right? So your two answers you should write as points, and there they are, written as points. Remember, answers are always written as points. Okay, our last question. I want you to try it all on your own. So we have two pairs here. You notice that we have two y squared, so that's going to make things a little bit different. But it's not going to be that difficult. You're still going to try to get your y squares alone, and you're going to try to get them to be the same. So you're going to want to multiply this bottom one by 2 to make it negative 4y squared plus 2x plus 4 equals 0. And you're going to probably want to reorder it so that it's in the same order, because we're going to notice that it's not in the same order. The x's are not in the same spots. In fact, that's just an x and an x squared. The y squares are not in the same spot. The constants are, equal signs are, zeros are. So we're going to reorder this thing. Okay, we're going to set up the whole thing that you can solve on your own, but we're going to reorder this so that the y squares are in the same spot. My first equation was x squared plus 4y squared minus 4 equals 0. My second equation, I had no x squared, but I had minus 4y squared, and I had plus 4. But these two x's, they don't match up with anything, so I'm just going to have to put plus 2x off to the side, like that. When we do this, we're going to choose to add them together. We're adding because our things are the same, which is our y squares. We have opposite symbols, right? We had plus 4 and negative 4. So when we add these together, you should get x squared. These cancel. You're going to get negative 4 plus 4, so these cancel. You have plus 2x equals 0. Hey, it's your job to factor that. Try it on your own. Maybe pause this video, try to solve it. I'm going to put the answer on the board, and then you can check. But I'm not going to show you the work, so you guys got to figure out the work on your own. I'm going to change my mind on that. I'm going to show you the work for this one, because the x values are easy, which is why I want to leave them to you. But the y values are going to be a little tricky, so I'm actually going to do this one with you guys. When we go to solve this thing, we're going to factor it. When we factor it, we just take out a GCF. So we're going to have x plus 2 equals 0. That means x equals 0 and negative 2. Alright, the reason why this is a little tricky is because we have an equation that's kind of strange with these y squares, right? So I'm going to choose to work with, let's work with this equation right here. And I'm going to sub in x equals 0. So I get negative 4y squared plus 2 times 0 plus 4 equals 0. 2 times 0 is gone to 0, so negative 4y squared plus 4 equals 0. This one's going to be easy to solve because we can get y by itself. So y squared is going to be equal to negative 4. Divide both sides by negative 4. The y squared equals 1. And we're going to square root both sides. When we square root both sides, remember we put a plus minus. So y equals plus minus root 1. That means when x equals 0, there's actually two different answers. So we're going to have 0 comma root 1. And we're going to have 0 comma negative root 1. And the square root of 1 is just 1. Right? So that is just 1. So it's 0 comma 1 and 0 comma negative 1. But I want to leave it as a root just so you can see like how it could look if it wasn't 1. So that would still be the same way if it was like positive minus positive or negative root 2. I would still write it like this. It would just be a 2 instead of 1. Okay, now we're going to do the same again, but we're going to put in negative 2 into our equation. So we're going to have negative 4y squared. And then we're going to have plus 2, negative 2, plus 4 equals 0. When we calculate that thing, 2 times negative 2 is negative 4. Negative 4 plus 4 is going to cancel out, so we have negative 4y squared equals 0. If we get that all by itself, we divide both sides by negative 4. And y squared equals 0. We square root both things. We do put a plus or minus in front of it, right? So we have y equals positive or negative root 0. The square root of 0 is 0, and plus or minus 0 is still 0. So it's just y equals 0. This answer actually gave us 3 points. It gave us 0, comma root 1, 0, comma negative root 1, and 0, comma 0. The reason it gave us 3 answers is because if you look at your question, this is not a quadratic system. This is a pretty wacky system. It's a radical system. It's something that we've never graphed or seen before. It's something that is designed specifically to solve through elimination, because it's a very difficult question to complete. You could not complete it. Well, I can't say you could not, but you would have a very hard time completing it using any other method but elimination. Okay, that does it for this lesson. So you should now be practicing on your practice booklet on 4.2. You should be done 4.1 and 4.2 practice before your quiz tomorrow.